What role does a capacitor play in an electric circuit? Well, perhaps the most important role it can play is to introduce an element of timing to an otherwise bland, static, or simple circuit. Let's see how this works. If you place a high voltage across a gas lamp, like a neon lamp, it will glow. Why is this? Well, the voltage is so high that the atoms in the gas become ionized. Electrons are stripped from these atoms. And these electrons conduct electricity and they start flying through the gas. When they recombine with atoms, they fluoresce or emit light. And that's the glow we see. But it would be obnoxious to have to sit there turning the switch on and off ourselves to make it flash. How can we use a capacitor? Here we see that the battery is attached by a large resistor to a capacitor. Initially, the capacitor is uncharged, and so there's no voltage drop across it. The lamp is wired in parallel with the capacitor, so there's no voltage drop across it either, and so no current flows through the lamp. The atoms are neutral. But as time goes on, we see that charge flows into the capacitor, and the voltage across it builds. This takes time, in part because we have a big resistor there that's limiting the current, and in part because the capacitor can handle a lot of charge before the mutual repulsion of those charges finally prevent more from entering. Once the capacitor is nearly fully charged, the breakdown voltage of the gas is reached, and the gas conducts electricity. It now has very low electrical resistance, and the capacitor discharges very quickly compared to how long it took to charge, and the lamp briefly glows. When a low enough voltage is reached for the gas to recover and totally recombine, the process starts again, and the gas is now electrically resistive. Different gases will have different breakdown voltages, recovery voltages, and also different resistances when recharging. I bet you could figure out what all of those are. In general, roughly, the amount of time it takes a capacitor to charge through a resistor is given by the product of the resistance and capacitance, RC, measured in seconds. So if you have a 6 megaohm resistor and a 6 microfarad capacitor, you'd expect about 36 seconds to charge. We've sped it up for you here in the animation, but the time values on the graph are reliable. The amount of electric potential energy stored in a charged capacitor depends on the stored charge and the voltage across it. When both of these are high, the stored energy is high. But the charge itself depends on the voltage for a capacitor, so there's a magnified effect. The stored energy depends on the square of the voltage. The stored energy in this capacitor is measured in millijoules, thousandths of a joule. Enough that you'd notice, though. So play around. See which combinations of resistors and lamps give the fastest blinking. Figure out which gas has the highest discharge resistance. Hope you enjoy.